equation for the reaction between ammonia gas and copper 2 oxide. Ammonia gas and copper 2 oxide. Do you have anybody that can write the equation for us? Before I do the reaction between ammonia gas and copper 2 oxide. Anybody that want to try? Anybody? So let me try it for you. So we have ammonia gas. The reaction is copper 2 oxide. Will give us, we have copper, we have water. So the product of reaction between copper 2 oxide and ammonia will give us copper, water, and nitrogen gas. That is one of the ways to prepare nitrogen gas in the laboratory. Is this equation balanced? Then let us balance it. 2 here. 2 NH3, yes. 3 H2O and 3 CuO and 3 CuO. So when ammonia gas reacts with the copper 2 oxide, the product are copper, water, and nitrogen. Then the next question. Ammonia gas with oxygen. Reaction between ammonia gas and oxygen. Reaction between ammonia gas and oxygen. Who wants to try? Reaction between ammonia gas and oxygen gas. Reaction between ammonia gas and oxygen. Reaction between ammonia gas and oxygen. Do you have anybody I want to try? Right. So the product of that reaction will be nitrogen and water. Then why don't you come and write it? So we are writing reaction between ammonia gas and what? Oxygen. Then the product will be nitrogen and water. It's not left for you to balance the equation. How to balance the equation? 2 what? Can I have it 2? That will be 4. 4, 3, then you have 2, then you have what? 6. So when ammonia gas reacts with oxygen, what you have is nitrogen and water. The next question there, we're also writing the equation between aqueous potassium iodide with chlorine. Reaction between aqueous potassium iodide and chlorine gas. Potassium iodide and chlorine gas. You should be able to write this. Reaction between potassium iodide and chlorine gas. Who want to try? This is very simple. You should be able to write this. Yes. So, reaction between yes. Chlorine will displace iodine from that solution. And what you are going to have will be potassium chloride and iodine. So that is right. Place flag for her. So then we have a equation between ion and dilute tetraoxosulfate 6. This is also simple. Who wants to try that? Reaction between ion and tetraoxosulfate sulfate 6. Iron and dilute tetraoxosulfate 6. You want to try? This one is also simple, yes. Let's have it. Reaction between iron and dilute tetraoxosulfate 6. So please clap for her. So this is also a displacement reaction. Iron will displace hydrogen. So the product will be iron 2 tetraoxosulfate 6 and hydrogen gas will be involved. Then finally, reaction between aqueous lead-2-trioxonitrate with hydrogen chloride. Reaction between lead-2-trioxonitrate and hydrogen chloride. Anybody? Reaction between lead-2-trioxonitrate and hydrogen chloride. This is also very simple. Do you have any other person apart from Victoria that can write the equation? Equation between lead-2-trioxonitrate and hydrochloric acid or hydrogen chloride gas. Equation of reaction is very common here. You know, what we did yesterday has to do with equation. That's question number 2. I mean, question number 3. Also, 5 good questions here now on how to write equation. So you are expected to know how to write equation for preparation of some gases and the salt, because the one we did yesterday was basically on the salt. This one is basically on gases. So lead-2 chloride and HM3. That is also right. But I've told you when you are writing the equation, make sure you write the symbol correctly. This or C look like small letter C. So that is right. So the product will be lead-2 chloride and trioxonitrate acid. Describe briefly the process involved in the extraction of tin from its ore. Describe briefly the process involved in the extraction of tin from its ore. Who, at least, you have been taught the extraction of metals. Now, who can explain briefly the extraction of tin from its ore? Yes, anybody? The extraction of tin is very simple. It's very, very simple. Who wants to try? This is bad. Now, crush and wash the calcitride, which is the ore from where you extract tin. When you crush, then you wash, then you filter. The first step was what? Crush and wash the calcitride with water, then filter. It is then, the ore is then roasted in air to remove impurities. But once you get the calcitride or the tin stone, crush it then you watch and you filter. Part of the impurity will remove. Then roast the ore in here to remove the remaining impurity. Then the pure calcitrite can now be heated with activated charcoal. What is present in calcitrite is tin. So it means you have extracted tin. That means tin is extracted by reduction with carbon. But before you carry out the real extraction, the impurity must be removed. And that is the whole essence of crushing the calcitrite, filtering and exposing or roasting the ore with here in order to remove the impurity. So that's a simple test. You know, you are not asked, yes? You have a question, yes? Let's just say.
You said activated charcoal. Can coke be used instead of charcoal?
The essence of having the chemical content of both charcoal and the coke is carbon. The oxygen, the removal of the reduction faster if the charcoal is activated. The whole essence of using charcoal or coke is to reduce the tin oxide to tin. But if we use activated charcoal, it makes the reduction faster. Name 3 uses of hydrogen. What are the uses of hydrogen? Yes? It is used in the hydrogenation of oil. That is production of margarine. That is right. Please clap for her. So the hydrogen of oil to produce margarine. What are the other uses of
It's used in filling balloon.
for filling balloon? Why is hydrogen used for filling balloon? It is light. And why is hydrogen preferable? Why is helium preferable to?
Because it's not
So you know it's not because it's not good for filling balloon as that of helium, because it is what? Combustible. So instead of using hydrogen, you prefer using helium. So what other use do we have? It is used as a rocket fuel. So let's move on to now state 2 physical properties of hydrogen. 2 physical properties. It's a colorless gas. It is lighter than air. Let's see the now, state the class of oxide to which each of the following compounds belong. State the class of oxide to which each of the following compounds belong. What type of oxide is Na2O? What type or class of oxide is Na2O? Basic oxide. Basic oxide. ZNO. So it's an amphoteric oxide. An amphoteric oxide. We have SO2. SO2. SO2 is an acidic oxide. That is also right. Then CO2. It's an acidic oxide. Then N2O. N2O is NO2 is what? A neutral oxide. N2O is a neutral oxide. Then move on to the number 5. I'll finish that before we move. Write the chemical formula of alumina. Come and write it for me. The chemical formula of alumina. What is chemical formula of alumina? Yes, please clap for her. Alumina is pure bauxite. And what's contained is aluminum oxide. Can we proceed? in the extraction of aluminium, state one compound that is used in the extraction of aluminium. State one compound that is used, one, to obtain alumina from bauxite. We want to extract aluminium. We use bauxite. Now, mention one compound that is used to obtain alumina from bauxite. That means the bauxite is an impure alumina. It's only when you provide the bauxite that you have what? Alumina. What are the compounds that can be used to get the alumina from bauxite? If you understand the purification of bauxite, this question will not give you problem. So what we do? Now, how do we purify bauxite? You know, there are two stages involved in the purification of, in the extraction of aluminium. Purification stage and what? Electrolytic stage. Now, how do we purify bauxite? What do we do? You have to heat the bauxite with concentrated sodium hydroxide. It means sodium hydroxide is one of the compounds used in that purification. It is when the bauxite is purified, you now have alumina. So once you heat the bauxite with sodium hydroxide, the pure alumina will dissolve in sodium hydroxide. The impurity will not dissolve. What do? You filter so that the residue will be the impurity, like iron trioxide and triazosilicate that are impurity present in bauxite. Those one cannot dissolve in sodium hydroxide. What do you now do? You wash, and once you filter, you wash it. You now add aluminum hydroxide to the complex in order to get more of aluminium hydroxide. When this aluminum hydroxide is now heated, you are now going to have the pure alumina. But still, before you can carry out the electrolysis, you must add cryolite to this. And what is the purpose of adding cryolite? It serves as electrolytic solvent, and it also reduces the melting point of alumina. What are the chemicals that I've added during the purification now? Could be what? Sodium hydroxide or what? Cryolite. That's the answer. Concentrated sodium hydroxide or the cryolite. They are the compounds that are used in the purification stage. As a solvent, what can be used as a solvent for alumina now? I've explained. That is what? The cryolite. Cryolite can be used as a solvent for alumina. Then we have name the electrode used in the extraction of aluminium. What electrode is used in that extraction? The electrode that is used in the extraction of aluminium. Yes. What is the anode? What is the cathode? Because you know the electrode is going to be made up of anode and cathode. The anode is made up of what? The cathode is made up of what? Anode is graphite, which is carbon. Cathode is also graphite, which is what? Carbon. That means both the anode and the cathode are made up of graphite. You see, once you carry out the electrolysis, you are going to have aluminum ion and oxygen ion. when the cryolite is added to this, it will split the alumina into aluminum ion and oxygen ion. Aluminum ion will migrate to the cathode. Are we together? When it gets to the cathode, it gains 3 electrons to become deposited at aluminium metal. Hence, you have extracted it. But the oxygen will migrate to the anode. What will the oxygen do at the anode? What will the oxygen do at the anode? If at the cathode electron is gained, what will happen at the anode? It will lose electron. The oxygen atom will lose electron to become what? 4 electrons will be lost to become what? Oxygen gas. Remember, the anode is made up of carbon. What do you think will happen between the oxygen that is deposited as anode and oxygen? So it means there is tendency that the oxygen here will react with the carbon to form carbon dioxide. What happened? That anode must be frequently removed to prevent such. That means intermittently the anode, which is made up of graphite, should be removed so as to prevent the attack of the oxygen by the graphite. That can be a question in another year. Why is graphite removed intermittently during the extraction of aluminium? That is what? To prevent reaction of oxygen with the carbon to form carbon 4 oxide. So let's continue. Give reason why the extraction of aluminum is expensive. Why is the extraction of aluminum expensive? Because the graphite must be continuously removed. You need to be buying graphite now. And if you don't buy it, what happens? There will be formation of carbon 4 oxide. So it is expensive because the graphite must be replaced at interval. And it also requires what? Much electricity. So that is where we are going to stop today. Till we meet on Saturday for our practical, enjoy yourself.